In this video, I'm going to be talking about the different patterns that we can see on the periodic table. A lot of these you may have already figured out from doing the activities that I have provided or just by looking at the periodic table. So basically what I am doing is I am giving you a tool to use to help you feel concrete in your answers. So one of the activities I had you graphing atomic radius. What you should have noticed is as you moved across the periodic table from left to right, atomic radius decreased. But as you move down the periodic table, atomic radius increased. So this has a lot to do with the size of the atom and the number of electrons there are. The more electrons you have, the more spaced out it's going to be. And when we talk about energy, the more energy an atom has, the more tightly compacted the electrons are going to be, and the closer to the nucleus they will be. So when I'm talking about energy, the energy I had you graph is something that we call ionization energy. It's just the energy required to remove electrons from an atom to turn it from a neutral atom to an ion. So that is why we call it ionization energy. And what you probably noticed is as you moved across the table, the energy increased. And as you moved down the table, the energy decreased. So when I was talking about how the energy makes the atom smaller, as you're moving across, and let's say we are looking at lithium and we're looking at fluorine. Fluorine has a lot of energy that is needed to remove electrons, whereas lithium doesn't have too much. So the less energy required to remove the electrons means that it has more space for those electrons to kind of feel free to roam around and be a member of society, for lack of a better way to explain it. Whereas fluorine, it has loads of energy. Right here, in this general area, it requires a lot of energy to remove those electrons. So fluorine, all of its electrons are pretty tightly packed there. They're all very tight and, like I've said, require a lot of energy to be removed because fluorine would rather take an electron away from something else than give it up. So this is why all of this column has a -1 charge, because it's so hard for them to give up electrons that they spend more time just trying to take them away from other elements than trying to give theirs away. The last pattern I want to talk about is electrons in the valence shell. Remember how I said the valence shell was, if we're looking at the energy levels, it is the last energy level with electrons in it. So as you move across the periodic table, you will notice the electrons in the valence shell increase all the way up until the point of them being full when you're looking at the noble gases. But as you're moving down the periodic table, the electrons in the valence shell they stay the same. All of these elements here have one electron in their valence shell. They all have more electrons, but they all have one in their valence shell. that has a lot to do with their characteristics and stuff that we learned about during the tour of the periodic table. So this was just a brief talk about the 3 most important patterns that you would notice on the periodic table. Wraps up the lesson for today, and have a great day.